Good morning to everyone. So first we discuss the signal. What is signal? Signal means which carry the information. Signal means which carry the information. A function of one or more individual independent variable which contain some information is called a signal. Okay, means the main criteria is which contain some information. Means a signal is a function of one or more independent variable which contains some information is called a signal. Means signal carry the information. Okay, there are different types of signal. Here we discuss two types of signal. Okay, signal basically two types. Continuous time signal, and another is discrete time signal. Okay, there are signal is two types: continuous time signal and discrete time signal. First we discuss the continuous time signal. Continuous time signal means continuous in nature, continuous in amplitude and time. Okay, which signal is continuous in time and amplitude is called the continuous time signal. Suppose a signal is represented by amplitude and time, which call the one or more independent variable. Okay, amplitude and time are variable. So continuous time signal means this is plotted here. Plotted the continuous time signal. It is the horizontal axis and this is the vertical axis. Horizontal axis is denoted by time period, which is denoted by t, and vertical axis is denoted by amplitude, which is denoted by a. So this is the continuous form or continuous time signal, means continuous in amplitude and continuous in time. Okay, this is called the continuous time signal. Sine wave signal is the example of continuous time signal. Okay, next discuss the discrete time signal. Discrete means at certain time of interval. Here the time is continuous, but here the time is certain time of interval is called the discrete. Okay, means continuous in amplitude, but discrete in time. Discrete means division or divided, not continuous. Okay, discrete means so continuous in amplitude but discrete in time. So this signal is this. Okay, this is the form of discrete time signal. Okay, here is time period and here the amplitudes. Okay, this is called the discrete time signal. So next discuss sampling theorem. Sampling theorem. What is sampling theorem? Means a continuous time signal convert into a discrete time signal. Okay, a continuous time signal is converted into discrete time signal by sampling theorem. Okay, so by the use of sampling theorem, continuous time signal converted okay into discrete time signal. Means this signal, this is the continuous signal converted by this type of signal. Okay, this is the discrete signal and this is the continuous signal with the help of sampling theorem. So what are the process of sampling theorem, or what are the process of continuous time signal converted into discrete time signal? First, continuous time signal convert into discrete time signal by sampling process. What is the sampling process? Okay, second is the number of sample to be taken depends on maximum signal frequency present in the signal. Okay, the number of sample to be taken, what type of sample, how many number of sample to be taken. Now the number of sample to be taken depends on maximum signal frequency present in the sample. So what are the sampling theorem? Sampling theorem, a continuous time signal may be completely represented in sample and recover back if the sampling frequency Fs greater than is equal to 2 FM. This is called the sampling theorem. Okay, a continuous time signal may be completely represented in its sample and recover back if the sampling frequency is Fs greater than is equal to 2 FM, where Fs is equal to sampling frequency, okay, and Fm equal to maximum frequency present in the sample. Okay, so the theorem is Fs greater than is equal to 2 FM. So if Fs greater than is equal to 2 FM, a continuous time signal completely converted into discrete time signal, where Fs is equal to sampling frequency and Fm is equal to maximum frequency present in the sample. So a continuous time signal is represented by here the T and here the amplitude. So a continuous time signal is represented this is denoted by xt, the amplitude is xt. This is the continuous time signal. continuous, okay, continuous time signal. If we convert, this is the called the time domain signal, okay, continuous time domain signal. If we convert in spectrum, if we convert just spectrum, so in frequency domain, spectrum means in frequency domain, the signal would be, this is the xt converted into x omega, okay, x omega, okay, this is the 0, this is the 2 pi fm, and this is the minus 2 pi fm, okay. This is the fm, minus of fm, and this is the plus of fm. This is called in time domain, and this is the called the frequency domain, okay. This like a time domain signal, and this like a frequency domain signal, same signal. This time domain signal converted into frequency domain signal, but not discrete time signal. This is the frequency domain of continuous time signal. This is the frequency domain of continuous time signal. How continuous time signal converted into discrete time signal? There should be a use of multiplier. There should be a used multiplier where xt is used. Xt means continuous time signal, and del tst is called the impulse time signal, If we multiply continuous time signal and impulse time signal, the output of the multiplier should be a sampled signal. Multiplier, basically a multiplier obey the sampling theorem principle. Okay, so what is the impulse train or impulse time signal? This is the impulse time signal, del tst. This is the impulse time signal, okay. This is the impulse time signal, okay. This is the impulse time signal. If multiply this signal and this signal, output is the sample signal, which is this signal, and this called a discrete signal. So a continuous time signal, this is called the sampled signal, okay. So a continuous time signal converted into this signal, a continuous time signal converted into discrete time signal, which is called the sampled signal by the use of multiplier. So in the multiplier, xt is called continuous time signal, and del tst is the impulse signal. So if we multiply continuous time signal and impulse signal, the output of the multiplier should be a sample signal, which is discrete signal. So a continuous time signal should be converted into discrete time signal by the multiplier and by the sampling theorem. This is called the sampling theorem. By the use of sampling theorem, we convert continuous time signal into discrete time signal. So this is the time domain signal. If we see its frequency domain signal should be a this okay, this is the frequency domain signal of sample signal. This is the time domain signal of sample signal, and this is the frequency domain signal of sample signal. So this is the 0, this is the FM, this is the minus of FM, okay, and this is the Fs, the middle portion is Fs. So it is the plus Fs, and this is the minus of Fs. This is the frequency domain of sampled signal. Okay, this is called the frequency domain of sample signal. Okay, so by the use of sampling theory, or by the use of sampling theorem, a continuous time signal should be converted into discrete time signal. Okay, this is the main fundamental concept. By the use of sampling theorem, we convert a continuous time signal into discrete time signal. So this is the continuous time signal, and this is the discrete time signal. It is also called the sample signal. By the use of multiplier, a continuous time signal converted into sampled signal. Okay.